today I'm going to talk about metallization. So let's start. First, let's talk about the full process of the metallization and semiconductor fabrication. So first, this is the full process of the semiconductor, making a semiconductor. So in this boundary that I drew a line in here, and in the upper side of this boundary we call it back end, and the downside means front end. So that we talked every class before, we talked about the front end, and packaging or metallization, something else, means back end. So this is the boundary of the semiconductor fabrication. And then the bell means back end of line, and FEOL means front end of line. So especially bell used a lot in the industry, but FEOL is not used in the industry. So we just call it front end and back end, or back end bell or front end. So it's just special characteristic of the naming. And let's talk about more about the metallization. So this is the process picture. And then in the past we just use aluminum a lot because it is very cheap. However, aluminum has many problems to make a better device performance. So nowadays we changed gauge material, metallization material, to make a better device performance. And also this is the current metallization process picture. So first we just put some oxide deposition on the surface, substrate surface. And then after we deposition the oxide, we should planarization oxide to do the next step. In the past, we didn't do planarization a lot because so the surface was so rough. So the adhesion between materials are not very good. However, nowadays we planarization the surface so to do the next step more better. So planarization can help to make a better adhesion between materials. So we should do the planarization in this step. And then we make a contact we do etching to make a contact. So this is the contact of that we etch. And then lastly, we make a barrier material deposition. We do a barrier metal deposition. The plug, like contact plug, is composed with metal. Metal is sometimes not good, doesn't have a good adhesion between interlayer deposition. So it means when we do develop or lift off to this material, contact material or something else, everything can be deleted after we do that work. So we should prevent that situation. So we want to make a better adhesion between metal and interlayer deposition, and also to protect the metal plug, we make a burial material deposition. So we do 4 steps to do a metallization. So let's talk about the AI spiking and electric migration. This is the part of the device. We put some aluminum on the surface in this situation. However, when you do next step, the aluminum can implant to the substrate surface. So it looks like very sharp, and so we called it aluminum spike. However, in this part, there are pin junction. There is already pin junction made in here. However, the aluminum implant through this pin junction, so that aluminum hate that pin junction. So that pin junction cannot work well because it's gonna be short because of the aluminum spike. So aluminum spike cause many problems to the device performance. And also, this is the example of the electromigration. When we do some process to semiconductor fabrication, we use electric field a lot. So when we put some very high electric field, the atoms of the material can move to each side. So when this part atoms move to the other side, Hill coke can be made, and then the void is the part that moved atom already. So void and Hillock can be made because of the electromigration. Then let's talk about the contact resistance. The contact resistance means this side part of the resistance. So if the contact resistance is very high, that cause many problems. This is the contact resistance and the transistor. So when the transistor we want to transistor work. However, if the contact resistance is very high, every resistance is influenced by a contact resistance. So the transistor cannot work very well. So transistors cannot show its performance or characteristic 100%. So we should make a small contact resistance to the transistor can work 100%. And then let's talk about the silicide. Silicide is very important concept to make a better adhesion between metal and substrate. So contact resistance is very important problem of the semiconductor fabrication. So we want to make a small contact resistance to make a silicide. So silicide is put between the metal and the substrate, but making a silicide is very hard because of the summer budget. So there are many issues in here. However, nowadays many semiconductor fabrication use the silicide to make a small contact resistance. So this is the way how to make a silicide, and especially this is the solid side. So it means we make substrate in here, and then make a spacer, and then deposition the metal, and then we etch the metal, and then just make a self-aligned silicide. So this process after this process, the result of this process, we called it silicide. So lastly, let's talk about the sheet resistance. Sheet resistance means we can get a resistance from this equation, and then this part, when we normalized it to this one, and this after the normalization we called it sheet resistance. So this is the how compare the way to compare other material. So we should know how to calculate the sheet resistance. So today we study about the metallization. Thank you for watching my video. Bye.